Okay, today we are going to deal with the topic membrane potentials. We will not go through the equilibrium potentials in this small video, but rather we will produce another. We'll go through the subsequent other videos as the time limit is set to be almost not more than 7 minutes for this video. So let's begin with the membrane potentials. So here in this diagram, it has been basically 5 different diagrams that has been shown here. You can see that there is this the diagram A, B, C, D and E. So these diagrams are quite efficiently explaining the thing. If you see closely that how what exactly do we mean by the membrane potentials. The diagram are taken from the book by Laurel Lee Sherwood, and then since we can understand this concept quite easily, let's have a look at this concept here through this very first diagram A, which has been shown that their membrane has no potential. So the blue one is the extracellular fluid, the red background here is the intracellular fluid across this lipid bilayer. There are basically two different charges, the 10 positive and 10 negative charges, which are neutralized by each other. Similarly, there are the same number of the charges, the positive and negative, and which are neutralized by each other, the positive and negative. So it means that there are no additional charges which has a which finds their way towards the lipid membrane. But when you see the diagram B, the diagram B shows that there are 15 positive charges at the extracellular fluid and 10 negative charges. So it means that those 10 positive charges will neutralize the 10 negative charges. However, here in the intercellular fluid, there are less positive charges than the negative charges. So these 10 negative charges, in fact, you can see that these 10 negative charges would not be able to find the equal amount of the positive charges, and hence these negative charges would tend to get attracted to wherever there are the counter charges, that's positive charges. So here in diagram C, it has been shown that now in the extracellular fluid, what has happened, those positive charges that they come and line around the lipid bilayer. And as you see here in the intercellular fluid, the negative additional charges which could not find the positive charge, they also come and line themselves towards the lipid bilayer. Now why is it so? Because these negative charges are attracted towards those positive charges across this lipid bilayer, and hence the charges which basically produce very tiny potentials, they align themselves in such a way that the potential gets developed across this lipid bilayer. Now when you see in our body, in human body, there is the concept of electroneutrality that exists. So you see that the entire extracellular fluid and then this intercellular fluid, they all in fact are most of these the fluids are neutralized by these two charges. As they meet, they happen to find the opposite charges, but those additional negative charges inside, you can see that's inside just here nearby this lipid bilayer, is not able to find the positive opposite charges, which in fact are on the opposite side, that is outside the lipid bilayer, and hence these additional positive charges are also not able to find the negative charges, and they get attracted towards these negative charges which are inside, and then hence they come and align at the interface of this lipid bilayer, and then they produce the membrane potential. Now this here in the diagram E, it has been shown, you can see that the positive charge and negative charges are quite less in magnitude in this A, and go to the B, the positive charges and negative charges are large in magnitude, and then C has larger magnitude for the same very the opposite charges across this lipid bilayer. So magnitude of the potential varies depending on how many charges remain unneutralized or remain not neutralized across the lipid bilayer. That is how the potential gets developed across the lipid bilayer. So what is the prerequisite for the development of the membrane potential? Is very straightforward. That is unequal distribution of the charges. So membrane potential, the unequal distribution of charge across the cell membrane give rise to a potential difference across the membrane, and this separation of opposite charges across the membrane is known as membrane potential. So I hope that this very the two different slides is able to impart the concept of the membrane potential to us, and then this video has helped perhaps to understand what exactly is the concept behind the membrane potential. Thank you for listening.